Hello, welcome to my YouTube channel, Trinity Tutors, where mathematics is brought to your doorstep. So we'll continue with our studies in statistics, and in my last video we looked at mean, group and ungrouped data. So we are done with mean. Like I said in the last video, if you have any question or problem that has been giving you issues, you can just put them in the comment section so that we can do it together. So we'll move forward to the median. Today we'll be looking at the median, and we said that the median is the middle score for a set of data that has been arranged in either ascending or descending order. So when we talk about median, we are talking about the middle number. That's why it is called median, the middle number. But before we do that, we need to arrange our data first, either in ascending order or descending order. And the formula for median when it comes to ungrouped data is n plus 1 all over 2 will give us the position. That's why we have nth. Will give us the position of the number, or let's say the position of that particular median in the data. We have two examples here that we are going to use to give us more understanding. Example 1 says calculate the median of 8, 12, 14, 19 and 11. So we have solution. Now this is what we call ungrouped data. Ungrouped there means that they are not together. We are not having them in a group or compatible form, but this is just a series or an outtray of data. So we have 8, we have 12, we have 14, we have 19 and we have 11. So the first thing we are going to do, according to the definition of median, is we arrange them either ascending order or descending order. So I would prefer to go with ascending order. We have 8. So when we say ascending order, it simply means we are moving from the lowest to the highest. So we have 8. After 8 we have 11, followed by 12, followed by 14, and then we have 19. So we have been able to bring it out in this form. So according to median is saying that the middle number is our median. So if we look at it, this is 1, 2, 3, 4, 5. What is the middle number? The middle number is 12, and 12 will be our median. But then if we don't want to go through that route, we can say, okay, fine, let's use our formula. What is our formula? Our formula is equal to median is equal to n. N here is the number of data that we have, or number of observation. So we have 1, 2, 3, 4, 5. That is 5 plus 1 all over 2. So 5 plus 1 will give us 6 all over what? 2. 6 divided by 2 will give us 3, which is the third number. Remember, it's giving us the median, is giving us the position. It's giving us the position. So it's telling us that the third number is the median. So let's see. This is the first number, this is the second number, this is the third number. So you see, whether we use the formula or we just check for the middle number, we will still arrive at the same answer. But let's if that trick will work in this second example. Remember, this is solution for example 1. This is example 1 solution. Now for example 2 says compute the median 3, 5, 7, 9. So remember, we said we'll arrange it in either ascending or descending order first. So we have 3 followed by 5 followed by 7 followed by 9. Now let's use the trick we did here first of all. You see that how do we get the middle number here? We can't get the middle number because we have just 2, 2. So you will discover that usually when the numbers are odd number, like what I mean by that is when the numbers or data that have been given to us, or the observation that have been given to us, happens to be odd, then we can easily get the median by just separating them, picking out the middle number. You understand? But whenever it is even, it becomes difficult to do. So what we just do, we use our formula. And what is our formula? Our formula is equal to what? N plus 1. So what is our n here? Our n is 4. 1, 2, 3, 4. That is the number of observation. N is number of observation. So we have 4. Let me write median is equal to 4 plus 1 divided by 2. So this will give us 5 over 2, which will give us what? 2.5. 2.5. So it's telling us that our median is in between what? The second and the third number. The second and the third number. You know, on the number line, when we have a number, permit me to have it here. When we have a number line, this is 0. Let's say we have the 0.5, we have 1, we have 1.5, we have 2, we have 2.5, we have 3, we have 3.5, and so on and so forth. So now this is 3, this is 2. Remember, this is the first number, this is the second number, right? So let's go on until we get to, so we have 4, we have 4.5, we have 5, we have 5.5, we have 6, and we have 6.5, we have what? 7, and we have 7.5. So if we look at the number line, we want to see the number that is in between 5 and 7. You understand? Because they are telling us, this is telling us that our median is in between 5 and 7. So what is that number in between 5 and 7? Where we're going to have the number, this is 5, this is 5, and this is 7. So we don't want to make use of decimal. So what is the number, whole number in between 5 and 7? It is what? 6. So our median is what? Our median will be equal to 6. Our median will be equal to 6. Although 6 is not part of this observation, but we just need to know that our median is 6, which happens to be our correct answer. So this is everything about median of ungrouped data. So we'll be going quickly into the median of group data for us to have better understanding. This is median for group data, the median for group data, and this is the formula for the median for group data. We have L subscript M plus N over 2 minus summation of F subscript P bracket subscript P all over frequency of the media class, which is FM. So what does all this mean? So the LM here is lower class boundary of the main class. What do we mean by lower class boundary? Now look at this question we have here. This is what we call grouped data, like I said in my previous video. When we have numbers in this form, such that we are having 10 to 20, 20 to 30, 30 to 40, they are grouped. That's why we call them grouped data. They are grouped. So we are having these numbers. So it's simply saying that between 10 and 11, numbers between 10 and 20, all the numbers between 10 and 20, that's what we are saying. So we just grouped everything together. That's why they are called grouped data. So this one is the lower class boundary and this is the upper class boundary. So whenever you have a question like this, LM is the lower class boundary. So wherever your model, your media class falls, anyone on this side will be your lower class boundary, and anyone on this side is usually the upper class boundary. So what is N? N is the number of observation. The number of observation. In this case, it's actually the sum of the frequency. The sum of the frequency will give us our N, which is the number of observation. And we have summation F bracket subscript P. This is the summation of frequency before the median class. We also have F subscript M. F subscript M is equal to the frequency of the middle class. So we are going to understand this better by the time we take one example. And we have C. C is the class interval. Class interval is usually upper class boundary minus lower class boundary. Upper class boundary minus lower class boundary. So in this case, we can say 20 minus 10 will give us 10. Or you can say 30 minus 10 will still give you 10. 40 minus 30 will still give you 10. 50 minus 40 will still give you 10. That's what we call the class interval. So we have a question here, and it's saying compute the median. We have sales and we have frequency. So as we can see, 10 to 20, the frequency is 2. 20 to 30, the frequency is 4, and so on and so forth. So the first thing we need to do, we need to create a column here for cumulative frequency. Cumulative frequency. Cumulative frequency there simply means that we'll have to sum everything together. So usually we start from 0 and add 0 to whatever number we have here. So 0 plus 2 in this case will give us 2. So 2 plus 4 this time around. 2 plus 4 will give us 6. 6 plus 3 this time around. 6 plus 3 will give us 9. 9 plus 7. 9 plus 7 give us 16. 16 plus 5 will give us 21. 21 plus 2 will give us what? 23. And finally 23 plus 3 will give us 26. So look at our formula. Median. You need to be very good at storing formulas when it comes to statistics, because these are the things that will really help you in solving problems. So before we know what our lower class boundary will be, we need to bring this out and solve for this. N over 2. This is the first thing you do. Now the reason is this particular formula gives us the position of the median class. It gives us the position where the median class is. So more like it gives us the signal per se, right? So this is N over 2, and we said N is the number of observation. So what's the number of observation in this case? 26. I said that the sum of the frequency will give you the number of observation. So you have 26 all over 2. By the time you divide this, you have, okay, let's just do it in a very 2 here 1, 2 here 1, and 2 here 3. So we have 13. 13 is our answer. So now you now go back to your cumulative frequency. Where can I find 13? You ask yourself, where can I find 13 in this cumulative frequency? Let's start from the beginning. Can I find 13 inside 2? No. Can I find 13 in 6? No. Can I find 13 in 9? No. Can I find 13 in 16? Yes, I can. So automatically, this will be our, this will be where we'll pay attention to. This will be where our median class will likely be. So from this particular class, what is the lower class boundary? The lower class boundary there is what? 40. So we have 40 plus, what's the next one? We've already solved this, and we said this is what? 13. From the simple mathematics we did here, we said this is what? 13. That's N over, or let's just do it. N over 2. What is N? N is 26. 26 all over 2 minus. We said that this summation F bracket subscript P is the sum of the frequencies before the median class. The sum of the frequency before the median class. What does that mean? If I add this in median class, if I add all this frequency, the sum will give me what is supposed to be here. So I have 2 plus 4, 6, 6 plus 3, 9. So 9 is what is supposed to be here, all over. Now this is FM. FM there means the frequency of that median class. What is the median class? We have highlighted the median class. What's the frequency? The frequency of that median class is 7. So we have 7. And we have C here. C is the class interval. C is the class interval. And how do we get the class interval? We get it from here. So we say 50, the upper class boundary, minus 40, which is the lower class boundary, will give us 10. So according to board mass, we have to solve bracket first. So we have 40 plus open bracket. This will give us 13 minus 9 all over 7 plus 10. It's a very simple topic. Plus 10. So once we do this, we are going to be left with what? 40 plus, so 13 minus 9 will give us 4 all over 7. 13 minus 9 will give us 4 all over 7. So what do? Let's multiply this. We are going to have 4, or we can just simply say 4 divided by 7. We are going to have 4 divided by 7. We'll have 0.571 multiplied by 10. So we now have 40 plus 10 times this will give us 5.71. By the time you use this to multiply this, you have that. So 40 plus 5.71, 40 plus 5.71 will give us 45.71. 45.71 happens to be our median class. 45.7 is our median class. So by the time you go through all this, the first thing you just need to do is to understand the formula. Once you understand the formula, then you'll be able to navigate through whatever question that may come your way. I believe that with this very example, you've been able to understand how to solve median for both group and ungroup data. Do well to subscribe and to like as well, so that whenever I drop any video, you'll be alerted. Thank you very much for joining. Hope to see you in my next video.